Hello, welcome back everyone. Happy Friday. Today, I'd like to give each hackathon group a chance to informally present what you've been working on to the class. Before we start with that though, would anyone like to bring up any questions or discussion points related to the material so far or assignment 4 or anything else?
Could you just remind us what's the timeline for assignment 4?
Yeah, great question. I forgot to announce that. So I've pushed the due date for assignment 4 was initially Monday at midnight, but I pushed it back to next Wednesday at midnight. I don't know. I'm like trying to balance getting through things quickly with giving you enough time. Does that seem like a reasonable time frame? Has anyone looked at assignment 4?
Yeah.
Okay. All right. If you haven't and you take a look on Monday and you're like, I need at least I'm never going to finish it by Wednesday. My goal is not to make you all stress out. So, let me know if we should stretch things out a bit more. Okay, so great question. Any other questions about assignment 4 or any of the material so far?
I have a quick one about the seaborne graphing bit.
Mm-hmm.
It said we're supposed. I'm just sort of confused as to like what data we should use to find the means that you want in each column. Because I was just assuming it would be like the percentage of words recalled in each condition, like against the total number of possible words participants could have recalled. But then the confidence intervals are like much smaller than the ones shown on the other graph. So I'm wondering if it's supposed to be like an average of averages or something like that.
So well, I guess it depends what your confidence is. So these are 95% confidence interval. So like 95% of the data, you're talking about the very last plot, the bar graph?
Yeah, exactly.
Okay, yeah. So for each condition, you want to plot the bar height is the you know what? So I see what I did there. What I actually want you to plot something different than what I described. So I'll that's why the error bars are big. What I want you to plot is the height of the bar should be the average amount, number of words or proportion of words recalled for that condition. So like number of words, number of unique words divided by total number of words in each list. And then the bottom of the bar should be the 2.5th percentile. So it's actually not a 95% confidence interval. It's which would be like 95% of like, well, you could think of it if you took like infinitely many samples with replacement from the distribution, what's the upper and lower 2.5 percentile of the means? That's not what this is. This is the upper and lower 2.5th percentile of the distribution across lists. So the wording is actually off there. So this is like 95% of the data, like including the lowest and highest bits of data, fall within this range. So that's what those error bars show. So they're much bigger than 95% confidence intervals.
So it's like, of the distribution that you're calculating the mean of, what is the like 2.5 and 97.5 mark?
Exactly.
Gotcha.
Exactly. Yeah. Yeah. So I want to, in a paper, you'd want to do something more like a standard 95% confidence interval. So like, you know, take the standard error of the mean and multiply it by like, well, 1.96 or something like that. If you wanted it to be, if, you know, you have normally distributed data and then you'd like add or subtract that. I wanted you to use the percentile function to actually like look at the like range or the distribution of values in your data set. So they're kind of silly error bars. You wouldn't publish a paper with these error bars, but it just to like get you using that function and getting used to making error bars with Seaborn.
Cool, that makes sense.
Yeah, that's a good question. Anything else? Okay. Okay, so that'll be due in, you know, it's currently set to be due at on Wednesday, this coming Wednesday at midnight. Yeah, so like I said, you should take a look at that soon if you haven't already. Okay, so let's move on to having a little like discussion about what each group has been doing with the Bob Ross data set. So we had each group kind of give a 1 or 2 sentence summary at the end of last class. But I thought today, to help like frame the discussions and help us get a little bit more out of it, I thought it'd be helpful first to like have, you know, someone from each group start by like reminding the class what your main question was. And then I thought, well, like one way to go through what you did would be to like screen share your collaboratory notebook and then kind of like walk us through what your approach was and point out any interesting figures or methodologies. Like talk us through, like, you know, if you have some clever hack, talk us through that. Or like bring up things that gave you trouble or like challenges that were or weren't expected, kind of things like that. And I thought we could spend, you know, something like 10 minutes or so from each group. You know, if something's especially interesting, we could spend longer. If we run out of things to say, we can spend shorter. So that's just a guideline. And then after we're done with that, I want to discuss a few more things once we're done with everyone's presentations. Also, like I'm hoping we can keep this pretty fluid. So like, you know, if you have questions or ideas based on what, you know, something someone's saying, then like just jump in and I'll kind of attempt to keep the groups roughly on time so we have enough time to get through everyone. All right, questions on that? Okay, lovely. Okay, so let me enable screen sharing. Great. And then who wants to go first? Which group?
We can go if nobody wants to go, I think.
All right. Jane, was that you? I couldn't tell who. Okay. Yeah. Okay, so cool.
So I can talk about originally kind of what we did. Basically, our idea kind of came from the fact that like sometimes watching him, he'll have this like beautiful scene or whatever, and then just put like a giant like black line through the middle, and I'm immediately like, you ruined it. What are you doing? But it turns into something pretty, I guess. So we were kind of interested in seeing whether we could splice some videos and use kind of object detection to see if an algorithm could predict kind of what that black line would turn into in the future. And, you know, are there strokes that are more indicative of what it's going to be, or, you know, can an algorithm predict faster maybe than a person or something like that, was kind of the idea. So yeah, I think Jane could talk about like our steps and things like that.
Do you know the Google like web app Draw Anything? It's like, or quick, maybe it's called Quick Draw or something like that.
Yeah.
That is like you draw, like, you know, the website will say draw like a basket, and then you'll draw, and then like Google's kind of image detection will have to, it's like Pictionary with a computer. There's a really neat paper by Judy Fan, I think was either the lead author or senior author, where she uses the like library that was trained on that to like look at if you're seeing a drawing like kind of be made, at what point do you start to get understanding? It sounds like super similar to what you're describing. It's potentially interesting other related work.
So can I share my screen? What screen am I sharing? Let me see.
Yeah, you're sharing. Yeah.
Do you see this code?
Yeah, we can see.
Okay. So so I think like in kind of simple words, you kind of wanted to know the abstractness and the complexity of the drawing and how it's related with audience preference. And in order to kind of measure this, we kind of thought the abstractness and complexity could be measured by how fast could the machine learning like acknowledge what object is the video of the drawing is going on. So like that big black line can be somewhere in the time it can be detected as like a true or a person. So for example, it could be the time that reaching above transfer will like plateau about like 80% that is sure that it's a thing that's correct. I think like the earlier it is, the simpler, less abstract the drawing is. And we thought the object audience preference could be related with like likes, views, and comments and shares. That can be measured. So we thought of making the AI to analyze the video by using kind of like moving window, but we're just thinking about it. We have not implemented this yet, and then see when it gets the content correctly. So we could either cut down the video or extract the frames out of the video, which was the 2 tracks that we were kind of trying. And so I was kind of trying to extract, cut down the video and try that on, thinking it set of one window. So I can extract what that is, like classify what's in the video of the clip. So we kind of use the PyTube to cut down, and the image AI, which Clara picked up. We had a lot of good resources that people Googled, and this one was to analyze the clip of the video that I wanted to like see if this like 10-second of video can be classified. And Washira, she also tried another way, which was like extracting the frame, which she will explain. And it was quite successful. She has some results, which was cool. I think she can share it.
Cool. Results, huh?
Well, okay, so I think I can only share when you stop sharing.
Yes.
Thank you. Okay. So let's see if we'll see this. Basically, after loading in the video, this is the first video I think of thought process, and then chunking them by a certain frame rate, we then just ran a object detection classifier that was able to thankfully identify that he is a person. And then we just tried some other frame where we wanted to specifically look at the painting more closely. And so this is kind of our current result, where it only identifies the hand, but pretty accurately. Yeah.
Did it ever get to the point where it was detecting objects in the painting, or?
Not well. I mean, I've kind of just been finding random frames at this point and then looking visually, but no, not at the moment. Though that would have been our goal. Yeah.
Cool. Really neat. So yeah, so what, like if you're going to turn this into like a research project, what do you think the next steps would be? Or like, what do you think the challenges are here?
So our teammates had a really cool idea, since the pictures are already feature extracted by people or AI, so it already has ground truth answers. It would be nice to train it and then test it on the brain, like video, either by frames or moving windows. So that would be our next step. And if we like push it farther, if some in this fantasy world, like we can also start how it correlates with audience reaction, like likes and share numbers. So we thought that was interesting.
Yeah, really cool. Neat. I don't know, does anyone else from the class want to like ask questions? Do you want to know how something was done? Do you have ideas?
Which object detection system did you use?
I think this was from what it was, CB2, this package, which allowed us to import actually, yeah, I guess it's from Image AI. Image AI was the one that provided the pre-trained model weights. But CB2 is the package we use.
Very cool. That's awesome.
So I'm curious about the, like how you were thinking about the moving window stuff, or like the sliding window stuff. So is it the idea of like you have a sequence of frames within some, time window, and then you want to detect, yeah, I guess I'm not quite sure about like what you get from a sequence of frames as opposed to just like an individual frame in isolation.
Yeah, so there's probably like two things we could do with like a sliding window. One would be just a sliding window within a frame, like within a JPEG, but that's kind of more nuanced. Another would just be to like, I'm imagining you could go frame by frame, and at each frame you might have some distribution of probabilities of whatever he's drawing in real time, something like that.
I see. So something like, I mean, you can imagine some model where like when you're drawing one object, the probability for that object should go up and everything else should be like roughly stable, except maybe stuff that it's obscuring, which would go down. So you've got like, your job within some set of changing probabilities over time, like a time series of probabilities, would be detect or make a prediction or estimate about which thing is being drawn, or most probably being drawn in that sequence, or something like that. Yeah, that could be cool. So that's cool. I was wondering if it was like you were applying a model that had been trained on like short video clips, in which case that might be an explanation for why it's like detecting the person, because nothing in the painting is moving. It's just the person moving. And then the other potentially weird thing is like so I don't know which specific model you're using here, but many object detection models and like use these features that are that essentially do like 2D Fourier decompositions of images, so that you like decompose an image into a weighted sum of like oriented Gabor patches. And my guess is that even though from a distance, the painting looks like, somewhat like a kind of a little bit blurry or stylized photograph, it's going to have different like spectral properties in terms of like the like 2D Fourier power spectrum of the image, like than a painting of a scene, even if it's depicted well. Like using a paintbrush is different from having like photons bounce off actual objects in space and be captured by a camera sensor. So like there's something about art that's different from a photograph where like you're somehow like hijacking some part of your visual system to create the impression of an object in the real world that you see, but the physical stimulus at the like lowest level like can be substantially different. Cool.
Yeah, that was one of our concerns since we knew that most models are trained on real pictures, so we weren't sure how this would work. So we have to try on like training with the like pictures in the video with the features already like modeled, like not modeled, annotated.
Yeah, very cool. Neat. All right. Well, thanks very much. That sounds that's great progress and really neat stuff. So, yay. Silent Zoom clap for you. Great. Which group would like to present next? I got some clap emojis. Excellent. So I think that was the group in room 2. So you've already presented, so perhaps one of the other groups could present. Do you want me to just pick? Okay.
I'm waiting for something to finish running to show people, so that's
okay.
I'm happy to present, but something is I screwed something up, so that was working. So I'm just trying to rerun. It takes a while to load everything, so.
Okay. All right. Well, as you frantically fix that, maybe we'll have the other group fix it. It's okay if it's not working. We'll sympathize. We'll all sympathize.
That's good. Ours doesn't work, so.
Oh, great.
So you can.
We want to keep the autocorrelation high, so.
Yeah, this can be sort of asking for your guys' help then, which cool. Maybe is just as useful for the team learning.
That's right.
So, hold on. Let me. Oh Lord. All right, my computer is really displeased for some reason. Okay. I can share. So what we were gonna do was, in theory, actually really simple, but we kept on running into these like sort of silly problems. And let me see if I can share. Here we go. Okay. So what we did is we wanted to look at the occurrence of certain like Bob Ross catchphrases over time in the data set. So what we have here is we're using, we ended up using this, I forget the name of the library, YouTube transcript API in order to get the transcripts out because we couldn't get the other one that Jeremy had suggested to work. But we have that works, so we can get the captions out, and it returns captions as a list of dictionaries with like various informations about essentially certain like utterances throughout the video. So we just turned that into a continuous like transcript, and then wrote a little thingy that can just go into the transcript and look for the occurrence of like any substring in it. And we even have it takes a row from the data frame and returns the integer of the number of times that phrase occurs. So like in whichever one's in the row 1, white appears 13 times. But like it won't like work to we can't add another column, which seems like a silly place to be stuck, but like this is somehow wrong, and I don't know how. maybe this is gonna be like some obvious.
So what does paint? Okay, so that's a good good thing to look at. So what does paintings dot this paintings dot apply everything to the right of the assignment operator? What does that return? Is that a data frame or
This?
sorry, no.
What?
So you're assigning the
This.
output of that whole expression to
Right.
a column of the data frame, but is that a series or data frame itself?
My understanding was that apply returns essentially, yeah, this will essentially return a column.
But we should check.
Like
you should check that
yeah.
though.
Okay, so but that in itself. Oh, another issue. Okay, I think if we run this, it's going to shoot us an error.
Okay.
Because there are like, my suspicion is that there are just like a handful of videos in that huge list for which the captions are either disabled or it just doesn't work. And so so I was gonna do like I tried like putting in a try except statement, but it didn't do what I wanted it to do. So maybe you could help me do that better. Which would go
Sure.
like here, right?
Well, you
Or
could just
here.
put, what you could do is just have like the entire body of the function you've written here can just be enclosed in a try block.
Okay.
And then colon, and then including the return statement actually. And then in the except block, I mean, this is kind of messy practice, but
I get the sense.
sure. But then you could just return 0 or np.nan for nan. In fact, yeah, so return that, yeah.
My lord.
Okay, and then so if it errors
Yeah, so
out
it
for any
says, like-
reason, yeah, that's fine.
Try this again, maybe.
Yeah, sure. Why not?
It does also take a bit. I'm not sure if that's an issue with my
Like
thing, or it's
timing.
just a lot of videos. I don't really know what this is doing, so
Yeah, I don't know that library, so I can't tell you that either. But it
seems to be taking a long time.
Okay, but the syntax you had looked right, at least at a high level to me. If the like paintings.apply statement crashes, that would explain why it's not working.
Okay, well, how about this?
But-
How about this? This works, right?
Okay.
So, and it seems to run fast. Why don't we make a dictionary that's just the number of the video and the occurrences of like the number, instead of amending it to the data frame, since that seems to be the problem. Like we can just make a new mini data frame essentially,
Sure. Yeah. I mean, I'm not totally following, but in
like this
principle,
works. I can take a row. This is taking a
Uh-huh.
row and giving back the number of occurrences of this. So I could just iterate through however many of the rows I wanted with with this integer, and we could just analyze like a data set that only has the number of occurrences of a certain phrase and also the video number. And we wouldn't be able to do analyses with any of the other data, but then we would at least be able to look at like the change of, I don't know, of his use of white over time.
Yeah. So, okay, I see what you're saying. So that sounds reasonable. Since this is taking so long, you could stop it, and then a trick would be to do paintings.head.apply, and that will just run it on the first.
How do I stop this?
Oh, you can't. It's going to take over your computer. No. Oh, there you go.
So now it thinks
a
they're
series.
all not an and.
Okay, so something's crashing in that function. So
Yeah.
that's the place to be.
But yet it works. But yet it works for this. Like for any given. Not for 5. It should work for. It works for some of them, or maybe none of them work now. Oh no! See now that this. See if I take this out though. Then.
Okay.
Because it was working before.
I'd be surprised if that now worked, but it should crash. Yeah, video unavailable.
It worked 2 seconds ago. Because I just had it here. Remember?
I do remember. Yeah. This is called the demo effect. Whenever you try to show someone how something works, it doesn't. It's a well-known phenomenon in the computer science field. Maybe some typo got introduced or what not. But I think in principle, what you're trying to do makes sense. So returning the output of the thing that got returned, it looks like a pandas series, which is like a data frame, but with only one column. You can create a new column with a series. And I think the syntax is exactly what you had. Obviously, if they're all nans or if the function crashes, it's not going to work. But yeah, that all looks reasonable. Another thing that could help with debugging here is paintings is a data frame, painting.head of something, like some number, like 5 or 3 or whatever, will return a new data frame with just the first n rows. And so that's a nice thing to debug on because it doesn't take as long as running on the entire data frame. Like if your data frame has 1 million rows in it, it's much faster to run on 5 rows than 1 million rows oftentimes. I mean, it's always faster, but if it's like...
This is actually what was happening before. A minute ago, like, I bet, is this not going to run anymore? Yeah, okay, see? So this happened before, earlier today when I checked this, like nothing was working. Like this was just always saying it couldn't get it. And they changed nothing. And 2 seconds ago, when I was about to introduce this started running. I haven't touched this.
Okay, I think I might know what's happening. My guess is that, so I don't know this library, but Google often places.
We don't really either.
Okay. Okay, so in general, it can be somewhat risky to just like use a totally random library. Unless you're kind of digging into what it's actually doing. So like it'd be risky to just download some random library off the internet and like import it into your Python package that you're working on, your analysis, because it's like anyone can post anything on the internet. So it's like copying code from the internet and running it on your computer. Like that could be risky. That being said, you're running here in a collaboratory session, so it's risky to like the instance of the virtual machine that this is running in, but it's not gonna like crash Google or crash your computer or anything. So it's not super risky in a collaboratory notebook. Usually Google places limits on how many queries you can run with a given API key. And my guess is that you've hit that limit. So if you wait a while, your like limit So it's like, you know, how many
What
queries
happens
per
when you
unit
try to
time.
run it on 400 rows?
Well, what
Is
happens
that
is
fine?
it'll say how many queries have you sent successfully in the past like hour, say. And if it's above your threshold, then it will
What
just
I'm
give you
saying
an
is like,
error
is it
every
is
time.
it ever going to work for applying this to every row then?
Well, I don't know what the limit is of,
Yeah.
of your key. A trick that sometimes works is to sleep for a short amount of time after each call, and that will stretch out how many times per second your API key is used. But then you have to like run it overnight or something like that, which can be annoying.
Okay.
So usually like interactions with rate limited API. Okay, so I'll have to cut this out of the video, but there's another way to hack your way around it, which is that you can, well, you'll have to look up how to do this. I don't think I should tell you, but it's Googleable. You can create API keys on the fly by essentially creating new Google accounts. So you write a little script to create a new Google account and then get an API key. And then once you hit the limit of one account, you just switch to the next account. So you can, yeah, I'm definitely cutting that out of the video though. But that is possible to do. I've actually used that for research purposes to like get around these limits, but they can obviously be used. That can be used for less noble purposes as well.
Okay, well,
they're discouraged.
Yeah, so that's where we are with this. It sounds like it's probably not going to work anytime soon for at least applying it to the whole data set. But that was the idea.
Okay, well, this is cool stuff. Yeah, and this also, like, I think we'll probably come back to YouTube transcript analyses when we talk about natural language processing, because they're like a fun thing to look at for natural language processing. So yeah, we'll revisit some of this. Okay. Very cool.
I'll go ahead.
All right. So thank you. Wonderful. So
I'm trying to
Zoom clap again. Okay. Well, Sarah, how's your you're good. It's working now. Okay. So maybe we'll switch to the room 3 group next. And we'll go from there.
So also, I don't know if anyone room 3 wants to talk or pipe in. Feel free to do so. Otherwise, I'll go ahead and explain things. But also don't want to dominate the conversation if anyone has something to add here. So the question you're sort of interested in looking at was whether certain colors show up more often in certain parts of the images, or maybe put another way, if a certain part of the image has a particular color that occurs most often at that point. And the thinking was, if we could sort of map that out, we could maybe start to then ask some sub questions related to that. If we could just sort of get a map of, all right, at this pixel, what color is most likely to occur here, and we could kind of get that data together. Maybe we could start asking questions like, where is blue most likely to occur, or something like that. We didn't get to that second stage, but we did finish the first part of getting a nice map together. So I'll walk through sort of what we did there. This first part is just copy and pasted over from the demo module to just import the data set and get the graphing function. But here, what we do is we just start off by loading every single image from the Bob Ross paintings that are available. So we just go through each row of the paintings data series. We get the image source, and then the function that Jeremy provided loads in the URL, loads the data for us, and then returns it as a matrix, which we append to our sort of growing list of all the images. And this is important because we need all the images in order to, let's say, take the average or take the median or take the mode. And I'll sort of talk through our process next for that. So we get all those together, and then we just sort of use a NumPy method to turn that nicely from a list into a nice NumPy array that has these dimensions. So it's 4 dimensions. The first is height of the image, sort of the height. Then there's the width, and then there's the color. So is it red, green, or blue? And then the index of the image. And if I do this, you'll see the images are all, this is very nice. We didn't have to do any resizing. All the images have a height of 337 pixels, a width of 450 pixels, 3 color channels, red, green, blue, and there are 403 images total. Now, something I later realized is I was modifying the values in this array. And so when I went to rerun the earlier thing, it didn't give me the same result because I had now modified it because things are done by reference. So I learned very quickly, I'll copy a backup here. So that's what that was happening in the background. I reran the earlier code here, and it looked different. So the first thing is I have shown here is the median, which worked the best. And so we just take, for all the images, we just say, hey, at each pixel, look at all 403 images and just take the median value for that particular color channel. So like for the red color channel, you know, in the, let's say, top left pixel, pick the median value for that pixel. And then this function sort of automatically does that for us. And it will just spit out then an image that is the median value across all the images at each point. And so you can already see some things here. There's blue at the top, likely because, you know, there's always sky at the top of the images. We sort of got brown or white colors, I think maybe because you have some trees or some mountains, oftentimes sort of in the upper portion of the painting. And then at the sides, at the bottom, we've got green because, you know, you might tend to have sort of, you know, sort of grass or bushes around there. And then there's this sort of different color area that could either be a path or a lake, or, you know, some sort of body of water, I should say lake, because again, you know, Bob Ross always sort of likes to throw that in, and you're not going to have, you know, a lake in the sky or something like that. So some sort of inferences you can already draw from this. Then we took the average, which you can't just straight up do the average. I looked into that. You need to like, also there's issues with sort of averaging RGB color for this. People saying use other color spaces, but we didn't get into that. So we sort of square all the pixel values, take the mean, and then you take the square root of that, and that gives you, I think, an appropriate average requiring the Stack Overflow. This did not look as good.
Yeah, interesting.
Not exactly sure why, but again, it could just be sort of the extreme values were kind of causing it to wash out.
It looks, so one way of dealing with that would be to do some sort of rescaling. So, because so if you think about like gray would be like, I think these go from like 0 to 1, the RGB values. So like 0.5, 0.5, 0.5 would be like, you know, 50% gray. But you could look at the direction of red, green, and blue relative to 50% gray as like kind of the like direction that the colors are pointing. So if you're like more blue than 50% gray, then you know that you're moving in the blue direction, et cetera. And then you could kind of amplify those changes. So say like, we're gonna like, you know, instead of moving from 0.5 to 0.51, you might move from 0.5 to like 0.9 or something like that.
Right.
Anyways.
Yeah.
Yeah, cool.
So one thing to sort of point out here is that this image sort of looks like it has a bit of a ring or sort of an oval shape around it. And so we thought that might be due to the fact that not all of the images are actually rectangular. And so if you look in the painting database, and I'll just give an example here. For example, this view from the park. It has an apple frame. I don't know what that means, but it's not the standard square frame. And so when you have a frame on an image, you get just sort of white values on the outside where the frame is, and they're just pure white values. And so the next step we decide to take is, well, those might be sort of throwing off our median that's being taken. So what we next did was try to get rid of all those white values by setting them to nan, not a number. And this is just sort of our exploratory code here. So this isn't actually used for anything here, but you can see all the different types of frames that can occur throughout there. So again, being copied the array, which did not do before. Then we find all the white pixels. And so just sort of break this down into the subparts. All images is again our big NumPy matrix. That's the width, the height, the color channel, and then the image number. So we want to say across, all pixels in the image and across all images for the where is the first color channel equal to 1, and where is the second color channel equal to 1, and where is the third color channel equal to 1. And when all color channels equal 1 in the same place, that's going to give you white pixels, the white pixel. So this thing here, which Jeremy helped us with, just gives us all the white pixels across all the images that we have. And then we simply loop through each image in our big image database. So the fourth, I should say, dimension is the again the which image it is. I will note here that because because all the color channels, we're selecting individual color channels and doing an and statement to each other, it just drops that dimension for us. So you'll notice there are only 3 dimensions here. But what we're doing is we go through each image and then we just say, essentially, set all the white pixels in that image equal to nan for each color channel. That's what this is doing. And so what we end up with is now the no white matrix is a matrix where each pixel that was previously white, which is it was a value of 1 in its red, green, and blue color channel, now has a value of np.nan. And then we take the median and the average. And an issue we had before was that it was all black. And then we realized, oh, it's because you need to say nan and median and not just median, which we had before. So we put nan median here. And then we take the median and then we take the average. And you can see here's what the median looks like. It's very similar to above. I'll show them the other one beneath it, but really not much change. It still looks like there's a frame around it, a ring. Now, that still could come about because even though we got rid of the white values, those frames still, they contribute at these edges and then they sort of stop contributing. They just get ignored here. So you might still have a bit of a ring effect possibly. Here's what the original looks like. So you can see if I can get a good, this is the, with the white pixels removed, and this is what we originally had. And they're very similar. Yeah.
One thing for this, shouldn't the effect of like elliptical frames be somewhat mitigated by the fact that you're taking the median?
Theoretically, but
another thing, there's actually
yeah.
from like a compositional standpoint, there's good reason for there to be a circle, like a circular sort of ring of like primary and like secondary sort of focal points of a painting is like a pretty standard composition. Also, like you always want to have focal points sort of off center, so you would expect concentrations of darker points to the left and to the right of center with the center open. And like I think they're like the ring could arise just like if you imagine your head a Bob Ross painting of trees in a lake. The trees are always on either side of the lake, normally with one bigger than the other, but that would even out. So like I think it is actually possible that the ring is real, which would be cool, I think.
Question too. Maybe we can check that hypothesis by just not counting in the images.
Yeah, you could take only one frame type.
Yeah, so that was going to be our original approach, but we ended up going with the setting the white pixels to nan, and then this just sort of, I mean, they're trade-offs, right? You know, one of the things that we didn't have time to look at, but would be interesting to do was to basically apply this method, but to individual features or collections of features. You might imagine, okay, what if we took all the images that had, you know, a cabin and I don't know, a certain type of tree or something? How does that compare to the images that are, you know, a beach and a boat or something like that? And you could try to start sort of breaking it down there, but we didn't quite get to all that yet. But yeah, there's a lot of questions you could sort of sub questions you could ask. Since we're running out of time, I'll just say for quick clarity here, I don't know if this is valid or not. I tried subtracting the two, and then it's all black, so I just pumped it up really high. So there appears to be there's some difference. It's not just the exact same image. And then here's what the average looks like, which is a lot more washed out. You can still sort of see general segmentation of areas. There's stuff here, maybe some like road or water in the middle, something in kind of the upper part, and then the kind of the blue and the white, but still washed out, and we might need to apply one of the techniques that Jeremy mentioned. So yeah, that's what we did.
Very cool. Yeah, really neat stuff. Okay, Chris, would you be okay if we switch you to Monday, like the beginning of class on Monday? I want to just say a couple more things. Okay, so at this point, I think you've gotten like at least some high level exposure to a few of the most critical libraries that you're most likely to use in your research. But before we move on to Module 5, I'm wondering if there are other libraries that you know about that you might want to learn a little more about, or like functionalities of the toolboxes we've looked at so far that you want to dig into. Does anyone have any like quick thoughts about that? Should I just pick stuff? Yeah, Stephen.
Maybe we could decide what a good candidate for this would be, but I think it would be really helpful to me if we like sort of did more of an in-depth look at like a particular library and maybe like discussed some like useful tools that we might not be familiar with. But we can see what.
Okay. I mean, NumPy or pandas would be like there, like pandas in particular is like very, very powerful. Do you want to do like a deeper dive into pandas? What would people think about that? Okay, I'll do that. Okay, so, great, lots of thumbs up. Let's do that. And then what about format? Did you like the kind of hackathon style, or do you want me to like do like shorter demos, like a more kind of hands-on, dragging you through decontextualized examples, but perhaps more specifically focused on particular functions? Would you like better?
I like the hackathon approach. Maybe it could be cool if we each were assigned like a focus for a hackathon approach too. Like use like this library and do something, and then each group can sort of like share what they learned from each library.
Interesting.
I don't know, or it could be a universal thing, but that way there's like some direction to it too.
Sure. Huh, that's an interesting idea. Okay. Well, why don't I dig up how about this? I'll dig up another data set that plays nicely with pandas. And then maybe we'll like go over a few like super useful functions at first. And then we can, if we, depending on time and interest, we can break off into groups and do, something with those functions. Does that sound okay? Have some head nods. I will take that as a confirmation. Lovely, thank you for the feedback. So I'll put that together for Monday. In the meantime, please keep going through the module 4 material and make sure to look at assignment 4 so that you can come in next week with any more questions about it. And until then, have a lovely weekend and see you all on Monday.